Good morning, HOD Professor, AK Sir, Vice Seminar Guide, SK Rathore Sir, Seminar Coordinator, Teacher Master, faculty members, examiners, and my parents. I am Tushar Yogi, pursuing my BTech from University Department of Mechanical Engineering, Rajasthan, Technology, Kota, Rajasthan. Today I am here to present my topic of seminar presentation on eco-friendly refrigerants. These are my contents of seminar. So let's start. First, the introduction of refrigeration. Refrigeration may be defined as the process of achieving and maintaining a temperature below that the surroundings, the aim being to cool some product or space to the required temperature. One of the most important applications of refrigerations has been the preservation of perishable food products by storing them at low temperatures. Refrigeration systems are also used extensively for providing thermal comfort to human beings by means of air conditioning. Now coming to traditional refrigeration system, the global warming potential GWP of currently used R134A is high as 1300. The ozone depleting potential Kyoto Protocol on United Nations suggests minimizing of hydrofluorocarbons to use as refrigerants. Research shows that HFC 134 is not much miscible with lubricant oil in oil compressor. R152 has been already approved for use in automobile applications. Refrigeration process. The working fluid used in the refrigeration system is termed as refrigerant. The mostly used refrigerants nowadays are a group of halogenated hydrocarbons marketed under the various priority names of freon generation, isotron, fusion, etc. These are either methane based or ethane based, where the hydrogen carbons are replaced by the chlorine atoms. Now, working fluid refrigerant. The mostly used refrigerants nowadays are a group of marketed under the various property names on freon generated, isotron, freon, etc. Now coming to types of refrigerant systems. Vapor compression refrigerant system. There are two types of vapor compression system: domestic refrigerant system, air conditioned refrigerant system. Vapor absorption refrigerant system, solar energy based refrigerant system, air cycle refrigerant system, steam and vapor jet refrigeration system, thermodynamic refrigeration system, and vortex tubes. Now components of vapor compression refrigeration system. These are the four main components in vapor compression refrigeration system: compressor, condenser, expansion mold, evaporator. So here are descriptions of all components. Compressor. Compressor may be of three types: reciprocating, rotary, and centrifugal. When the volume of flow rate of the refrigerant is large, centrifugal compressors are used. Rotary compressors are used to small units. Reciprocating compressors are used in plants up to 100 tons capacity for plants of higher capacities. In reciprocating compressors, which may be single cylinder or multi-cylinder one, because of clearance, leakage past the piston and valve throttling, the actual volume of the gas drawn into the cylinder is less than the volume displaced in the cylinder. Condenser. It must be superheat and then condense the compressed refrigerant. Condenser may be air cooled or water cooled. An air condenser is used in small unit. Water cooled condensers are used in large installation. Expansion device. It reduces the pressure of the refrigerant and also regulates the flow of the refrigerant to the evaporator. Two widely used types of expansion devices are calibrate tubes and throttle valves. Calibrate tubes are only used for small units. Once the size and length are fixed, the evaporator pressure, etc. get fixed, no modification operating conditions are possible. Throttle valves are used in large unit. These regulate the flow of the refrigerant according to the load on the evaporator. Now coming on evaporator. A common type of evaporator is a coil raised on the plate, called a plate evaporator in a fluided evaporator. The coil is filled only with the expansion coil. Water or brine may be chilled in the evaporator, and the chilled water or brine may be used to cool some other medium. Standard vapor compression refrigeration cycle. Process 1 to 2. Isentropic compression of saturated vapor in compression process 2 to 3. Isobaric heat rejection in condenser process 3 to 4. Isentropic expansion of saturated liquid in expansion device process 4 to 1. Isobaric heat extraction in evaporator. Now coming to environmental impacts. Ozone layer depreciation, the first major environmental impacts that struck the refrigeration based industries is ozone depreciation potential (ODP). Due to man-made chemicals into the atmosphere, about 90% of the ozone exists in the stereo between 10 to 15 km above the Earth's surface. Global warming potential (GWP). The second major environmental impact is GWP, which is due to the absorption of infrared emission from the Earth, causing an increase in global Earth surface temperature, while solar radiation at 5800 Kelvin and 1360 Kelvin, and most of the remaining radiation passes through the atmosphere and reaches the ground. Now coming on eco-friendly refrigerants. The most environmentally friendly refrigerants are hydrofluorocarbons (HFC) and hydrofluoro HFO. In today's modern world, because of the demand of power also increased power consumption, ozone layer depreciation is available. The main aim is to introduce the portable refrigerant unit using module with help of DC supply. The DC supply is provided with the help of buck converter to vary the temperature by adjusting its voltage. Now coming to merits of eco-friendly refrigerants. It is cheap. Weight per PR is low and hence ideal for aircraft refrigeration. No leakage problem. It is non-flammable and non-toxic refrigerant. Low maintenance cost. Charging of refrigerant is very easy. Similarly, there are some demerits also of eco-friendly refrigerants. It's absorbed heat as sensible heat only, hence mass compared to the other refrigerants. Low coefficient of performance. Freezing of moisture at low temperature. Lower coefficient of performance compared to the other refrigerant cycle. Running cost is high. Conclusion. The discharge temperature and the discharge pressure of the compressor were found to be lowest for HCM when compared with other mixtures. Reported the lowest vapor pressure among the mixtures, which reduces the heaviness of the components of the refrigeration system by using the blend. The average pressure ratio for HCM 7:30 was lowest with the value of 4.3, which promises that the life extension of the compressor. The average input power to the compressor for HCM 7:30 was found to be 9.5% lower than R134A. Usage of this blend reduces the power consumption of the system. The heat removal rate was higher for HCM 7:30. These are some reference on my topic. Thank you. Any questions?
No.
Thanks.